All right, we just finished our first unit on basic graphs, basic models, and basic equations. And for the rest of the semester, we're going to add 2 more layers to that, an intermediate layer and an advanced layer, but the same thing, graphs, models, equations. And then at the end of the semester, the last thing we're going to do is add in some technical stuff that we need just so that you can communicate well with the scientific community about all the things you've been learning, how to apply those things. So for this next unit, the first thing we're going to look at is intermediate graphs. And we're going to break that up into 2 pieces. The first piece that I'm going to talk about in this video is how to take a graph, take some basic shape that you already know, and move it around. So you want to be able to slide it up and down, left and right. You also want to be able to flip it. You want to flip it vertically or flip it horizontally. You also want to be able to stretch it or compress it vertically or horizontally. So we'll talk about, well, I'll hint at how to do all of those things. I'll at least give you an example of how that can be useful. And then in the homework, you will work through how that plays out. So I will lead you in the homework into how to figure out each one of those individual steps. But a good example of how this type of thing plays out is, let's say I'm going to take this camera case and I'm going to throw it to you, okay? And I want you to catch it. All right, here we go. All right, let's say that we want to come up with a model for how that camera case flew through the air. So maybe think of the center of the camera case, the center of gravity of that thing. As I threw it to you, let's say it went up about 4 feet in the air, and let's say it went out for 6 feet. Then we can graph it. The flight of that camera case would look something like this, where the max height would be 4 feet, and then it hits the, let's say it hits the ground. Well, let's say that from the height that I threw it, that's this height, it went 6 feet before it came back down to that same height. So maybe if I started it at 3 feet in the air, it went 6 feet before it came back down to 3 feet in the air. So this is the model that we want. Now I want to come up with an equation that gives me exactly this. I want it to be as precise as possible, because in mathematics, we want to be able to use equations that represent physical things and economic things exactly, as precise as possible. If you're sending somebody into space and you're trying to bring them back to the Earth, you want to be able to make calculations as precise as possible. And there are many other examples where you want to make extremely precise calculations to be able to model something. So what I'm going to do is take this basic shape, which is the shape of a parabola, and think about how it would extend out here. And I know of a simple equation that will give me the graph of a parabola. I know if I just think of this equation, y equals x squared, the graph of that is a parabola. That's a quadratic equation. I remember it goes through the origin, because when x is 0, y is 0, it opens up. I remember it looks something like that. So if I'm going to start with this and be able to get it to this, I'm going to have to do a few different things to it. Number one, I'm going to have to be able to flip it. So I'm going to have to be able to flip it upside down. I'm going to have to be able to move it to the right. Since this is symmetric and this goes out to 6 feet, I know this will happen at 3 feet. So I'll have to be able to flip this over. I'll have to be able to shift it over to the right 3, and then I'll have to be able to shift it up 4. But that's not all I have to do. If I do all of those things, then this is what my graph will look like. I flip it over, I move it over to the right 3, I move it up 4. So if this is 3 and this is 4, and I know my vertex of the parabola is at the right place, but the way that it will actually look is something like this. It's a little too narrow. So what I want to do is I want to be able to compress this vertically or stretch it out horizontally so that it exactly fits what I want. I can show you how to do this. I can show you how to get it exactly from here to here, but instead of just working it all out for you on the board, I'm going to try to lead you through that in the homework, and then of course I'll be putting up solutions videos in the homework to help you with that as well. So this is just a little motivation for why we would ever want to have things like this. It's an extremely useful technique for graphs and models. If you continue to take mathematics after college algebra, then this is a technique that you'll almost surely use. Super useful.